All right, hey, Math 20-1. So we're getting into now something called rational expressions. Um, and just like it says at the top of my web page, you can see that as an intro to rational expressions. It's really, like it says down here, a rational expression because it is a ratio of two polynomials. So that's where the word rational comes from, is from ratio. So it's just a numerator over denominator of polynomials. So of like x squared plus 5x plus 2 or something like that, right? So it's not a rational expression if it was just like 9 over 2. So just to give you a little context, let me go back. Okay, so what we're going to be doing is taking these rational expressions, so things written with like, p's or x's or, this is, some of them look more like this as you go down. It's just simplifying them. So the first part says simplify each and state the excluded values. I'll show you what I mean by simplifying first, and then next I'll show you what I mean by excluded values. So simplifying this, you can see we can break this up into really two things. You've got 30 over 25. So really we can just simplify that fraction, right? So we can say, okay, what goes into 30 and what goes into 25? So that's 5, right? Goes into both those. I can divide 30 by 5 and 25 by 5. So that fraction alone, if I wanted to simplify that, I could rewrite that as 6 over 5. I'm going to leave this kind of long because I'm going to have an x somewhere too, right? I'm going to rewrite what I have up here, this 30x squared over 25x, just to kind of show you what I mean. I'm going to rewrite this x squared as xx. And on the bottom, I've just got 1x. So the simplifying thing that we're going to do is you can see that now I've got two x's up top, one on the bottom. One of the x's is going to cancel with the x on the bottom. And what I'm left with is just 6x over 25. So that's how we simplify these rational expressions. And some of them are going to be more difficult than that, but that's really the basic idea. We want to find common things in the top with common things in the bottom, and then cancel them. That's going to be the trend through this whole unit. Okay, so that's what I mean by simplifying. And then next, what I mean by excluded values. I'm just going to erase this for a second. So excluded values, the way you have to do excluded values is you have to look at the original expression. So I can't look at my simplified expression. It has to be this one, the one up top. And excluded values means what is x not allowed to be? So the excluded values. And what I mean by that is what number are you not allowed to divide by? So let's say like you've got some number. So I was going to put like a number symbol for that. Some number divided by, well, you're not allowed to divide by 0. If you take any number and divide by 0, that's not even infinity, it's nothing. Your calculator will say undefined. It's saying that no, you're not allowed to do that. So we're saying what would x have to be down here in order to make the denominator equal to 0? Well, x would just have to be 0, right? So what our process is going to be here is we're going to go 25x is equal to 0. This one's straightforward enough. You can just see right off the bat that x would have to be equal to 0 to make that equal to 0. But you can, as we move down, we're going to have to do a little bit of algebra. So you solve for this and say x is equal to, divide both sides by 25, divide by 25. 0 divided by 25 is 0, so x would have to be equal to 0. So really, though, you're saying x cannot be equal to 0. So in the end, your excluded values, you'd write like that. So x cannot be equal to 0. So let's move down a little bit and do a little bit tougher one. You guys are going to go ahead and do all of them, but I'm going to just do a few for you here. So this one says p squared minus 2p minus 3, and then all over p plus 1. What I would do off the bat is I'd do the excluded value first, because I said you have to do it right off the bat. So again, we're saying, okay, what would p have to be equal to make the denominator equal to 0? Because that's what we can't do. It can't be equal to 0. So we'd say p plus 1 is equal to 0. And then p is equal to negative 1. So p cannot be equal to negative 1. That's what our restriction is there. That's the only thing that p is not allowed to be. If you're wondering what that looks like if you graph it, I don't know if you are or not, but if you are, that would be a vertical asymptote if you graph that at -1, but that's for another day. Okay, so we know our restricted value is not allowed to be 1. Now what we got to do is simplify up here. So what we need to do with these ones, do you remember all that factoring that we did in earlier units? Well, that's where it's going to come in handy. So we're going to factor the top. And if we do that, you end up with P. Well, maybe I'll break it down just so we can remind you here. It's going to be P and P. And then remember, it needs to multiply to this number and add to this number. Well, the only numbers that can multiply to 3 are 3 and 1. And then they need to multiply to -3. So one of these has to be negative, one has to be positive. So it's going to be -3 and +1. And that way they both add to -2, right? -3 plus 1 is -2. So that would be factoring our top. I'm going to write on the bottom P plus 1. The brackets didn't matter, but put in brackets anyway. But now you can see I've got something on the top and something on the bottom that are exactly the same. P plus 1. So what you can do now is I can cancel those. So P plus 1 cancel. So this written simplified would just be P minus 3. And technically the way you should write these, the full way you would write it would be, we'll go back to purple. P plus 1 and then comma, and comma in math means where P cannot equal 1. So that would be the full answer there. Just remember that the comma means where. So P plus 1 where P cannot equal 1. Crap, I made a mistake, sorry. That should have been P plus 1. P minus 3. Hopefully you were wondering what was wrong with me. It's P minus 3 where P cannot equal 1. Sorry about that. Okay, so I'm going to move down. Let's go to 15 just to do a little bit tougher one. So if we're looking at this one, we're going to do the same thing. So we're looking at the denominator here, and we need to figure out, all right, what is x not allowed to be to make it equal to 0? But this is pretty hard to tell from looking at it this way, right? What's going to be a lot easier is if we factor everything. That's going to be an ongoing thing that we're going to factor the top and the bottom of both. Hopefully you like factoring. So let's go ahead and just factor the top and the bottom. This might make a bit more sense. So if we factor the top, that's going to be x minus 6, x plus 1. I'll let you guys go ahead and see if you can figure out how I did that. The bottom, what I'm going to do on the bottom first is I'm going to factor out what's common to each of these three terms. So what's common to each of those? There's an x in every one, right? So I can pull that out. I can pull it out to the left. There's also 2 goes into each one of those. So I'm going to factor out 2x and then write down what I have left. And what I have left is going to be x squared plus, oh, my pen's off, plus 5x plus 4. And then what I'm going to do, maybe I'll put an equal sign to say this is equal to that, equals, and then just rewrite the top because I'm not doing anything with that yet, but we do want to factor the bottom one more time. What I can do is write this part. I can factor that again too, right? That's going to help me out because that's written as a quadratic function. So we're going to write that as bracket, bracket, x, x. So something that multiplies to 4, adds to 5. That's going to be 4 and 1. And they're both adding, right? Okay, now we're in a situation where we can actually see how this is going to be handy. So we're going to look at the bottom. So we're going to look at the bottom right here. So just looking at, this. And I want to figure out what x can't be to make it equal to 0. So what I'm going to do is take that whole expression, move it over to the side here maybe. I'm going to write it again. 2x, x plus 1, x plus 4. And I'm going to make that equal to 0. You guys will probably start being able to do this in your head a little bit later, but I'm just going to show you. I'm going to set that equal to 0 to figure out what does x have to be to make it equal to 0. There's going to be a few situations here. There's going to be this. What does x have to be there to make it equal to 0? What does it got to be there to make it equal to 0? And what does it have to be there to make it equal to 0? The first one, 2x, to make that equal to 0, well, on that one, x would have to be equal to 0, right? So maybe I'll do the whole long way. So let's say 2x is equal to 0. In order for that to be true, x would have to be equal to 0. So that's number 1. So we'd say x cannot be equal to 0, I guess. The next one, x plus 1. Let's go x plus 1 is equal to 0. Well, that would mean x would be equal to negative 1. So we're saying x cannot be equal to negative 1. That's one of the restrictions too. And then the last one, x plus 4 is equal to 0. We're going to say, well, x cannot be equal to negative 4. So that's my other restriction. So there's 3 restrictions there. Okay, so I figured out my restrictions now. And then last thing I got to do, let's just simplify our equation over here. And you can see that on the top I've got x plus 1, and the bottom I've got x plus 1. Let's cancel those. So x plus 1 and x plus 1 there. And then just write what we have left. So we have left x minus 6 over 2x times x plus 4. So that's simplified. And then you'd say where, so comma, x cannot equal 0, negative 1, or negative 4. So that would be my answer there. So okay, now I'd like you guys to go ahead and do all the questions that we haven't done here. Just know that the answers are written here. So the way they look here, so this is x, the first one we did. That number in brackets is the non-permissible value, is the way they've written it. So yeah, so make sure you guys go ahead and do that. That's for homework. I want to see that that's done, and I'll see you guys in class.